Welcome all to the second and concluding part of the live session where we are conducting a COVID-19 lockdown analysis using big data analytics. For those of you who haven't attended the previous session, we have already compared the countries which have imposed complete lockdown with restriction rules and analyzed the variation in their number of COVID-19 cases, as well as taken up a hypothetical situation of the effect on the COVID-19 trend in the US if in fact they would have enforced a lockdown a couple days earlier. In this particular section, we're going to determine which Indian states need to continue the lockdowns in the coming days, and we are going to fetch the list of it. So we are going to be using these two data sets. One is of the patient details up till 19th of April, and the second one is up to 26th of April. Now the data set consists of details regarding the patient number, which state does the patient belong to, the date of announcement of the case, estimation of onset date, the age bracket, gender, detected location, current status, type of transmission, and the sources from which the data is collected. Now, as we just saw, the dataset is stored in two CSV files, both of which we have loaded into our Hdfs directory. This is what the data flow diagram looks like for this particular problem. We're going to be using Hdfs for data ingestion from our CSV files and also to transfer the aggregated data from Hive, which would be analyzed using Apache Spark. Then we're going to be reading the aggregated data using Scoop and write it in my SQL database. So as I had already mentioned, I have already uploaded both of these data sets to my Hdfs directory. Now let's log into Hive and create a database. Now this might take some time, so kindly be a little patient. Okay, so with that we have logged into Hive. So let's go ahead and create our database. So I'm going to name this database COVID data underscore analysis 101. Just remember to give it any unique name and not the name of a database which already exists. And now we're going to use it. All right. So now I'm going to set the header while printing output query and also create an external table. Don't worry if the code is going on too fast for you. All you need to do is understand the flow of this entire process. All the code, as I've mentioned in the previous part, will be provided to you in the description box below. All right. So now we have created an external table with columns and the column formats. All right. Okay. Now to verify if both of my files are loaded correctly to the destination path, let's just run this. All right. Now you can see all of this data on the 26th of April. Yeah. Okay. Now to better understand this data, we can just go ahead and run a few queries, such as the type of transmission. Now, since it's a fairly big data set, it's a fairly huge data set, all of these queries are going to take some time, but it shouldn't take more than a couple of seconds. We can also query for the current status. All of our statuses are listed here. You have your deceased, hospitalized, migrated, and recovered. Now what we're going to do is that we are going to create a dynamic partitioned table, okay, and go ahead and load our data. Now these are the same rows we had previously for the external table. As you can see, you have your gender, you have detected city, you have current status, so on and so forth. You can just go up and take a look at the previous table, but obviously that'll have so many lines of code that you'll have to go through to get there. All right. So now we're going to overwrite the patient details partition. Okay. Now, a lot of you might be wondering, why am I not typing things straight away into the command line? Why am I using the notepad to type it out and then paste it here? And that's only because of I feel it is more convenient to type things out in a notepad. I'd rather you type the entire code out on the notepad and then run it, because you're less likely to make mistakes on the command line if you just have it pre-typed on your notepad. You can spend some time there, come here, and execution will be much easier for a demonstration like the one I'm giving you all right now. Now what I want to do is find out the difference or compare the partitioned table to the unpartitioned one. So this is querying the partition table. So partition table here is basically about distributing, let's say, portions of your table data across the file system based on your partitioning function, or let's say some rules. Yeah. So what I'm running right now is your non-partitioned table. And now let's go ahead and run your partition table, which took much lesser a time than the partition table. Now, because in this case, the data is physically stored in different partitions, each partition we can actually access separately, which actually makes it much quicker to run. It's better manageability, maintenance, locking and blocking. It improves scalability, availability. So it's basically an approach taken in many large scale solutions to reduce contention and optimize the performance, as you could just see. The non-partitioned one took so long, but the partitioned table query ran so immediately. If we suppose try to again find out the date announced, the count from the patients in Kerala, this is definitely going to take some time. So I would like to take this time to encourage you guys to go ahead and check out our big data training program. We have several of them depending on your requirements. I'm pretty sure my team will be very happy to leave out certain links in the chat. Just going to run a couple more queries. This one is for detected state and date announced. We're going to count the imported cases from our partition file. So you can actually go to edureka.co, type in big data. And you can go ahead and check out Edureka's Big Data Hadoop certification training. You can see the schedules, you can see the syllabus. It's a pretty extensive syllabus curated by industry experts. And you can go ahead and check out certain tools such as Hdfs, Yarn, MapReduce, Pig, HBase, Oozy, Flume, and Scoop. At the end of it all, you will be working on real life industry use cases in retail, social media, tourism, so on and so forth. and you can get access to the Cloud Lab that I'm using right now, so you do not have to spend hours and hours to download the VM on your hardware. Let's go back and check. All right. This one's all done as well. And with this, we've counted the number of local and imported cases per state in the previous query and local ones in this query. So yeah, you all can use this time during self-quarantine and upskill yourselves, get yourselves more market ready by the time the lockdown is over, because the market will bounce back, and by that time you will be ready for your dream job. So just a thought, I shall close this and let's see how far have we come. Okay, with that we're all done with Hive. We are going to quit it and clear our screen. All right. Now we're going to log into Apache Spark so that we can access our files in Hive using Spark. So Apache. So this is also going to take this time. So this is also going to take some time to get us logged in. Now basically Apache Spark is an open source distributed general purpose cluster computing framework, which basically will give you an interface to program entire clusters and perform implicit data parallelism, and it'll help you with fault tolerance as well. Okay. So now basically what I'm going to do is run a couple of commands so I can access Hive through here. So we are accessing all our assets. All right. So now because we are taking this from our CSV, our date will be in a string format. What we're going to do is convert it to a proper date format so we do not have any inaccuracies, inconsistencies from the information that we are asking from our tables. Then we're going to sort our data by date, aggregate our current status, and sort everything by our formatted date column. Okay, and we're also going to omit our null values. Now, based on our current status, we're going to create a pivot table. Okay, then. All right. So basically, we have pivot our table from a wide format to basically a long format. If you can see, it was first, your primary column was your date, and you would see the count per state per day. And now you have your state and your stats till date. Now what we're going to do is that we're going to filter our records post the imposition of the lockdown. So basically filter our data after the 24th of March, on which day India imposed its lockdown. Okay, we're going to group it by our detected state and our date and pivot it around by the current status. And remember, all of these tables are supposed to appear filled to you. If it doesn't, there must be some problem regarding you loading your data files to your Hdfs directory. Make sure you do that first before you run any of these commands. And make sure you replace all the files with your local path and do not blindly copy the code that shall be provided to you. Okay, now what we're going to do is we are creating an extra column on this. We're calling it zone. And this is basically going to be a Boolean, a binary output column. It's going to give you a 1 if your number of hospitalized people are greater than 10 and 0 if they are under 10. So basically, we are trying to find out our danger zones. Now we're going to highlight our red zones, which correspond to the value 1. Now out of 34 days, which is 24th March to 26th of April, if more than 15 days the new cases are increasing, it can be considered as a red zone area and lockdown must be continued in those states, right? Make sense? So let's do that. Let's filter. If the count is greater than 15, we are going to sort our table by count. Okay. Now remember, have patience. All of these queries take some time to run. This is going to take a fair amount of time. Okay. So it's basically showing all of these states which have more than 15 cases between 25 days. Now we've already gotten our red zones and all that's left to do is to save this. Okay, so now what we're going to do is we're going to sort this entire thing. Okay. Now all that's left to do is to store the result to Hdfs. So now all you have to do is export the aggregated data from Hdfs to MySQL table that you've just created using Scoop. For that, you need to run this particular command. Now I have already done it, and then you can go ahead and verify if your data is loaded into your MySQL table. From that table, you can fetch the list of Indian states where the lockdown should be continued. Here, if I list out the contents, you can see I have this red zone states. Now, if you fetch the data from this, you'll basically get the names of all of your states that are your red zones. With that, I come to the end of my session. My name is Upasana. Thank you and have a great day.